Hi everyone. This lesson is called Notation for Cube Roots and Square Roots. So write that on your paper and write today's date. And for most of you, today's date will be February 4th, unless you're doing this at some other time. And you are going to turn in your notes from this. Okay, yesterday you were asked to write down all your perfect squares and cubes and square roots and cube roots. If you didn't complete that, I wish you would pause this and try to do it on your own first. If you have completed it, just skim this and make sure you have the correct answers. And I want to just point out a couple things about the notation. When you write the square root of 100, the answer is 10. And that is because 10 and the square root of 100 are literally the same number. The square root of 121 is just a fancy extra way of writing the number 11. And I'm saying this because there are many times that I see students take the square root of 144, and instead of just writing a 12, which is the correct answer, they'll write 12 squared. But that's wrong, because the square root of 144 literally is the number 12. It's not the number 144. The square root of 144 is literally the number 12. So just remember that when you write the answer to a square root, there's not an exponent. Same thing when you write the answer to a cube root, there's not an exponent. That's all. And again, double check your answers, and we'll move on to the next slide. So today we're going to look at how a different way that we can notate square roots and cube roots. And you might have done this earlier, so this might be a review lesson for you. But I would like you to copy what's on this slide. And then I'll talk about it after you copy it. So you might just hit pause. So the exponent 1/2 is the same thing as a square root sign. Okay, these are exactly the same. So if I write 25 to the power of 1/2, that's the same thing as a square root of 25. And in a way, this is cool because all three of these are ways to write the number 5. Right? I think of this as like 5 in disguise, square root 25. Then here's 5 trying to be all fancy. 25 to the power 1/2. Why are you trying to be all fancy? You're a 5. Okay, now when you have the power of 1/3, then that's the same thing as a cube root, and you put a little 3 here. Okay, so the number 6, if it wants to get fancy, it can make itself into the third root or the cube root of 216. And by the way, that's how we say it, the cube root or the third root of 216. And this would be 216 to the power of 1/3. Or just 216 to the 1/3 power. Or 216 exponent 1/3. All the same. Notice when we write a square root sign, we don't have a number here for the index. There's no number here because the square root sign is like the OG square root, and everybody else is just like a little copycat. So when you see an exponent that is a fraction, and I would like you to write this one down, just pretend like n is any number. N is just a random number. If you see this exponent, that's a fraction. The top number is the power. I mean, technically the whole thing is the exponent, but the top number is the power, and the bottom number is the index or the root. And I'll show you a little bit more about that. And it's actually on the next slide too, so I'm going to go ahead and switch on here. So if you have some number and a fraction exponent, which is what we call a rational exponent, then this rational exponent, when it switches into radical notation, this top number becomes the exponent inside the radical, and the bottom number becomes the index, or sometimes called the root. Okay, and then just a couple other vocabulary words. This symbol is called a radical symbol. And the number inside the root symbol, the number inside the radical, is called the radicand. And actually it comes in handy to talk about the radicand sometimes instead of always saying the number under the square root sign. So make sure you've written this down and that you know the vocabulary word radical and radicand. So if you see a number to the 1/3 power, then technically, and I would like you to write this down so you know how these work, the 1 comes over here and becomes the exponent of the number, or the power of the number. The 3, and you write it small, it sits on this shelf. It should be written smaller than your other numbers, and that means that we're taking a 3rd root. And then we don't show an exponent of 1 in, if it's in a fraction, you have to show it. But if it's not in a fraction, we just don't write exponents of 1. So really, when you see n to the 1/3, it's just a 3rd root. But I did want you to know that that 1 does go somewhere, because later these won't always be 1s on top. So anyway, write that down. Then I just wanted to show you that also when you have the power of 1/2, according to the rules, the 2 would go here as an index and the 1 would go here. But no one writes it like that, because you don't show an exponent of 1. Because if we don't see an exponent, we automatically know that it's a 1. So don't bother writing that. And we don't write the index of 2, because this radical sign, if you just see a radical with no little index, we all know it's square root. So nobody writes the 2 there. Okay, so when you see something to the power of 1/2, you just go straight to square root. And when you see something to the power of 1/3, you go straight to cube root. In fact, I think I wrote that. I thought I wrote that. I guess I didn't. Okay. So on this slide, I wanted to tell you that in math, the term rational is often used to mean fraction. So when you see a fraction exponent, we actually call it a rational exponent. And that comes from, in math, the word rational is similar to the word ratio, which means fraction. So in math, we use rational to mean fraction. So those are kind of synonyms in math. So make sure you get that down, that these are called rational exponents. So here you're supposed to rewrite these radicals using rational exponents. So on your paper, I should see you write square root of 43, and then you're going to write it with an exponent, and then cube root of 17, and then you're going to write it with an exponent. By the way, these don't have a perfect answer, so don't use a calculator or anything. I'm just looking for you to write 43 to the power of 1/2. Okay, and then here, you're going to write this 19 to the power of 1/2 with a radical sign, and the 17 to the power of 1/3 with a radical sign. And again, these don't have perfect squares or perfect roots. I picked some that didn't have perfect answers. Okay, if you see a perfect square or a perfect cube that has the rational exponent of 1/2 or 1/3, unless the directions tell you otherwise, just write the answer. So if you see 144 to the power of 1/2, you don't have to write square root 144. You can literally just write 12. And if you see 125 raised to the 3rd power, you're not required to write, the 3 and the square root sign. The radical. You just write the answer, 5. So write those 2 down. You don't necessarily have to write all the words. Just write down those problems and the answers. And then this, I wanted to just point out that you can evaluate variables that are under radical symbols. So when I see a square root and I have 36x squared, what I should be thinking is, can I multiply 2 identical expressions, and get 36x squared? What are the 2 identical expressions that when multiplied together would equal 36x squared? And then for 64w to the 3rd power, what are the 3 expressions that I could multiply together that are identical that would equal this? Now remember, don't write all 3 of them, just write one of them. And why don't you pause and write down those answers in your notebook, and then I'll mention them also to see if we got the same answers. Hopefully you got 6x there. And hopefully you got 4w here. Okay, because if I did 6x times 6x, I'd get 36x squared. If I did 4w times 4w times 4w, I'd get 64w cubed to the third root. Okay, and I just wanted to pop back for a minute and make sure that you had the right answers on this screen. So here, you should have written 43, that's a 3, with a little tiny exponent of 1/2. Make sure you make your exponent up high and small. And then 17 with an exponent of 1/3. Over here, you should have just written square root 19. If you wrote a 2 there or a little 1 here, I probably wouldn't mark it wrong, but I'm just going to ask you not to do that. It just doesn't look educated. And then over here, because it's a 1/3 power, you want to make a little 3, little tiny 3 as your index on your radical sign, and a 17. That's it. Okay, the next thing that's going to happen, just so you know,